All right, we are live. Hi, everyone. I'm really excited today. It's a special guest for me. Like, I admire Ian for all of his work and development. He's my role model. So I'm very excited to host you, Ian Keough. He's the CEO and founder of Hypar. One thing I really like about Ian is his whole journey and how he developed various products along the way. So I would definitely like to cover that in this interview. So thanks a lot, Ian, to be on the show. I know like super user disruptor are like some of the adjectives which definitely fits your role, but um, I'm happy to host you.
I'm very happy to be here, Myra, and I have to congratulate you. Congratulate you and thank you because you are incredibly active on Hypar's Discord, for instance, where you're just like constantly dropping in like really cool stuff that we all should be knowing about, thinking about in AEC. And I think you are also of a generation that is like much more facile with the social media platforms in terms of like getting the message out there and fostering these kinds of conversations. I have at times like tried to be really good about this and do live streams and stuff, and I always kind of fall off the wagon, but you're like, your cadence is incredible. And so I love the fact that you're putting out all these like really incredible, interesting conversations. So thank you for that.
Thank you. So before we kick off, and can you tell us what's your background, where you grew up, and out of all things you could do in life, why you chose architecture?
I didn't choose architecture. Well, it's funny. I chose sculpture originally. I chose fine arts. So about halfway through high school, I was like, I'm doing art school. And so I kind of like let math and science and everything else slide. And I think it was because a lot of the concepts as they were teaching them in the big Midwestern high school where I grew up in Michigan, they weren't like really connected to reality. I remember taking calculus and thinking like, okay, these are these like functions that are these machines. And if you put in the numbers in the right sequence, like you get the right answer, but I don't understand what this stuff is for. And the person who taught my calculus class was also like the baseball coach. And like, it wasn't like a master teacher of calculus. I don't think even he had like a fantastic grasp on calculus. So I just was like, I was really into drawing, and like I was doing these charcoal drawings, and I was starting to do like sculpture and all kinds of photography and everything else. And so I was like, you know what, I'm just going to go into fine arts. And my parents are incredible in that they never said like, oh, that's a bad idea, you should go get it. Like they were just like, you'll figure it out. So I went to the University of Michigan and got a BFA in sculpture, and spent a year in Italy learning to carve marble, learned how to cast bronze, which was a huge deal for my dad because he came from the metal castery and the foundry industry. So he was always like really excited that I was learning how to cast metals and stuff, and just had a fantastic time. And then after undergraduate, I was living in Michigan thinking like, I'm going to be a sculptor in Southeastern Michigan, which was kind of funny because, there was a lot of opportunities for sculptors. And also this was 95, so like we were on the internet. I think the internet was like starting and everything else, but like the idea that you could like, work all these angles to like find other opportunities and go do something lateral to sculpture just wasn't even like a thing to me. I was like, where are the jobs for sculptors? And I'd like go by parks and see like a sculpture and say like, I could do that, And so I went to New York City because my then wife, or then girlfriend, now wife, lived outside of New York City. And she was like, look, come and crash at my place. And I got a job in the MoMA bookstore. That was like my first job in New York City. And it was the most terrible job because you have this like idea that everybody's coming to the Museum of Modern Art to like really appreciate art, but they all just like zoom through the museum, they see the lilies, and then they go to the bookshop and they buy like, they all buy the same thing. They all buy like, the postcard of the Jackson Pollock or the Jasper Johns flags. And then they, and so it was only like a couple months I was at that job before I got a job actually at an architectural fabrication shop. So a company called Ada Inc. on the West Side that was doing fabrication for artists and architects and all kinds of stuff. And it was basically just an opportunity to use my sculptural skills for something. and I was building all this crazy stuff and going weird places and installing sculptures and artworks and architectural like pieces for people. And the story that I always tell about how I got started in architecture. I mean, first of all, my brother was an architect, and I told you right before the call that everybody from University of Michigan is walking around with a huge smile on their face today because we beat Ohio State last week. But he was in the architecture school at Michigan when I was in the sculpture program downstairs. And so I would go up like in the middle of the night when they closed like the foundry where I was doing all the bronze casting and stuff, and see him, and he'd be up in the studio like cutting basswood models. And so he was already an architect, and I had some sort of idea of like what it meant to be an architect. But we were working in this dusty shop with respirators on and Tyvek cover suits, and Liz Diller, we were doing a project for Diller Scofidio, and it was the Brasserie restaurant in New York City. And we were making the green resin tabletops. If you've ever been there, they have these like kind of shimmery green resin tabletops. They look like candy. And we were making all those tabletops because we knew how to cast resin and stuff. And so Liz Diller walks into this scene, and she's like so cool. She's got this like slim black jeans and these like clunky boots and this big silver puffer jacket. And I'm like, is that what an architect looks like? I want to do that. So I told, I was just about to get married. So I told this job that I was quitting. And I went to graduate school at Parsons in New York City and got a graduate degree in architecture. And then immediately decided in graduate school, I didn't want to be an architect. That is, I didn't want to be like a design architect. I got really turned on to the work of engineering firms like Arup and Bureau Happold. And this is where our stories kind of collide a little bit. My structures professor, Greg Otto, worked at Bureau Happold, and he was like, hey, look me up when you're done with graduate school, because we were going to start hiring architects, because they had this like feeling that architects were kind of going to be important for the future of like modeling, all the 3D stuff that they were starting to get into, and it wasn't being taught in engineering schools. So I looked him up, and he was actually surprised to see me. I like just walked down to Bureau Happold's office on Chambers Street, knocked on the door, and I was like, I'm here. And he was like, okay. So he gave me a job, and like that job, as you know, Bureau Happold like just does amazing things. But because I was like one of the first architects to work in the New York City office, at least, they just gave me everything to do. They didn't know what to do with me, so they gave me everything to do. And it came over time. What sort of emerged was this pattern of like, we're working on these really complex projects, and they were either complex because they were geometrically complex, or they were complex because there was some analytical aspect of the project that was complex. But in both cases, what they had was a lot of different software that didn't talk to each other, but they had like APIs, or in the case of the structural analysis softwares, they had text file formats that you could like inject data into and get data out of. And so I started writing software, which is the weirdest thing, because like I had always like really been interested in computers and everything else, but it wasn't something like I didn't learn to program growing up. And of course, this was still like 2001 or something. Like this was like very early on, or maybe it was like 2004-ish. And so there wasn't like, there was no Stack Overflow, right? So the joke that I always make is like, when the first Revit API came out, I was throwing up like little message boxes that said like, you made it to here, and the value that you want is this. Because I honestly, I didn't know how to use a debugger. I didn't know anything about programming. And the resources, I would go downstairs from Bureau Happold. They'd moved their office down to 100 Broadway. And I'd go downstairs to the Barnes and Noble bookstore, like a bookstore that sold actual books. And I just sit in the section where they had the computer books. And I would just read. I never bought any of the books. This is why Barnes and Noble went out of business, right? Like I would just sit there and I would read books about like how to program, and then go back upstairs and work until, late into the night. So that just became like, I became a kind of a resource inside Bureau Happold. Like I started working with other offices all around the world. And then I was like, whoa, there's like not people doing this. My assumption was always that like the engineers were so smart, they must be doing this themselves. But the engineers weren't taught to do it either, And so I'd get a call from Kuwait, and they'd be like, we have this crazy project, this crazy building. And at the time before the financial crash, just crazy. We were working on crazy projects in the Middle East, and they'd come to me and they'd be like, we have this thing and it's shaped like a crescent and it has to stand on its point and it's 50 stories tall. And like, and we're going to analyze it, but we need to do this and we need to do that. And like, we need special software to, you know, make the geometry or analyze the thing. And so that's what I did. You know, I started making software, and all of that kind of parlayed. You know, at some point I'll get concise in how I actually describe this story, but that always seems to take like 10 minutes. You know, at some point that parlayed into the first sort of proper software that I wrote, which was a BIM visualization application for the first generation iPhone. Because, you know, it just seemed to me we were like working on these. The moment of reckoning for me was actually they were building the Fulton Street Transit Center in downtown New York. And those of you who have been to New York know that the Fulton Street Transit Center is this kind of like nexus of all these subway lines. And it was a huge capital works project for the city of New York for years and years and years, trying to figure out like how we can put a transit center on top of this thing. And they were doing all the World Trade Center development and everything else. And Grimshaw built this like beautiful sort of conical, you know, thing with an aperture at the top, this atrium. And they were just coming up out of the ground with the steel. And I remember I'd walk to work down Broadway, I'd get off the train higher up, and I'd walk down Broadway. And every day I'd peek through the construction barricade. And I'm not kidding you when I say one day they're just coming up out of the ground. So there's a bunch of girders that are running into each other at ground level. And there's a steel worker who's standing on these girders. And it's a complex structure. You know, they're just about to take off this big conical thing, which I'm sure lands on this structure. And then there's crazy stuff going underground in New York City. And the steel worker is standing next to a column and on one of these girders. And he's got this enormous set of plans. And he's looking at the plans and he's kind of like thinking about it for a second. And then he does that thing that's like in every like, you know, jungle movie where the guy, they're like, we've been walking in circles for hours. And then the guy like turns the map over. He does that with the plan. Way. Like, and I'm like, in today's day and age, you know, we've got these mobile devices that are like super powerful. Like, why is it that we can't like take complex models that we're making and take them to the site with us and not be like looking at drawings, you know? And so that kind of started me down the rabbit hole of, you know, starting to look at game engines and stuff like that. Is, you know, a lot of people are talking about Unity these days and Unreal and everything. The first app that I released was actually a Unity-based app. And this is more than a decade ago. And it speaks to the power of Unity that thing even back then was thinking about, we're going to deploy all these mobile applications. And then, you know, built that app, and then a proper software company came knocking, and I jumped out of practice as it was, and into software development full time. And I sold this app to this company, and then, you know, there's a whole story after that, but I mean, there's probably other things that will unfold out of that history in the course of our conversation.
Yeah, I was thinking like there are so many threads I could touch upon, but like it's a great story. Yeah. I was wondering, like, so you had that light bulb moment when you saw that architect, okay, I want to be architect. Like, what happened actually in architecture school that you decided you don't want to be an architect?
I guess what I noticed is that, and I'm sure this is not true of all architecture programs. So I don't want to say this about, and in fact, I know it's not true of all architecture programs, but Parsons was amazing. I should also say that it was a fantastic experience. I met great people there. And the professors were great and everything else. But I remember when they made us read like Gilles Deleuze, and I was like, what does this have to do with buildings? I didn't understand. And I'm still a bit thick that way. Like there's all this philosophical stuff that they make you read about space and the formation of space and everything else. But at the end of the day, like at 2 a.m. in the morning, we'd still be cutting these like basswood models, you know, because Parsons, unlike Columbia, where I had applied and been rejected, didn't have 3D printers or laser cutters or anything else. So we were still like doing this very manual stuff. And there was just this big disconnect between the like physical making of things, which I had been doing previously, like in a fabrication studio, making stuff that had to stand up, and this kind of philosophical stuff that we were doing. and I just gravitated naturally towards the making of things. And so, our construction technologies classes, my structures class, hypar is actually that word, which is a contraction of hyperbolic paraboloid, is based on a book, Trog Systeme by Heino Engel, that was introduced to me in my structures class in graduate school. It was just like fascinating to me that there were these measurable sort of structures out there that like you could measure things about buildings, whether it was forces or whatever. And so I just kind of gravitated towards that stuff. And I looked at people who were going out into practice, and I looked at my brother who was, working at Gensler at the time in Detroit. And I thought, I just don't know if like drawing elevations of things is for me. At that point, I was also starting to use Maya, which was weird inside Parsons. And maybe I had started doing a little bit of like scripting of Maya. And I was like, man, this like geometry stuff I had an affinity for because of my sculptural background and stuff. So when I got out, I just was like, I had seen a presentation on Buro Happold's wheeled and downland grid shell, this like timber lattice. I mean, you've probably seen it, right? They show it's such an amazing structural project. And also geometrically and from an analytical standpoint. And I saw that and was like, I want to go work there, like the place that did that. And and then I just never kind of looked back. I thought about it at some points, like I started doing ARE hours and everything else because you could do that at Buro Happold. But at some point I was like, who am I kidding? I'm not going to like actually get a stamp, Yeah.
And were you at any point considering dropping out from the program?
No. That's the interesting thing. It's short enough. I'm like a very long, I have like a very long view of the universe in general. 3 years comes nowhere close to like when I would ever drop out of anything. So like, I was just like, okay, well, maybe I don't want to be like the philosopher architect. Like everybody just was kind of vectoring to be Rem Koolhaas. I was like, I don't really care about that. But I was doing interesting stuff. I still had my structures classes. I still had my construction technology classes. I was making these models and doing this cool stuff. So, they actually bought a 3D printer, one of those very early Starch printers in the Parsons is a big design school. It's a fantastic design school. And they have a product design department, which was across Fifth Avenue or whatever. It was in a totally separate building. I found out that they got this printer and I started making 3D prints of models, and that like turned me on. I was like, this is super cool. And they found out that I was using this printer because this guy, Arthur Spivey, who ran the print lab, was letting me in there. He thought it was totally cool that they weren't just printing shoes and the other stuff that the product designers were doing. Like we were printing building models. And so he would meet me on the corner, and I'm not kidding you. He would meet me on the corner of Fifth Avenue with a box with a model in it that he had printed because we had to do this like cloak and dagger kind of handoff of models so that they didn't know that the architects, because they were worried that all the architects would come over and like start using this printer. And they had one of them and it was very slow and expensive. And so, there was just plenty of interesting stuff to do. So I never thought about quitting.
I see. And I'm curious to know, so you started in the sculpture program, then architecture, then in a structural design firm, you stepped outside our field and work as a developer, then in a software company at Autodesk, and then Hyper. Like, how has your philosophy or perspective about AC evolved through time?
It's fantastic and also sad. I will say, so I started the Dynamo project in about 2010. Maybe the first nibblings of it were made in like 2009 or something. It was really like 2010 if you go back through the timeline at Buro Happold, because we were working with HOK here in LA on the Anaheim Regional Transport and Intermodal Center, big complex geometry kind of building, and we had to deliver this Revit model. There's lots of stuff that's been written about the history of Dynamo, so I won't belabor that. But I was writing this thing, and we were solving this problem that we needed a Revit model at the end of the day. Revit couldn't do complex geometry, so we needed complex geometry. So we wrote this software on top of it. Buro Happold had tons of tools that we'd written over the previous few years about like getting stuff into Revit. And everybody was using what was when we started on the project called Explicit History and then became Grasshopper. And I hope I get my history right there, but I think that's about what happened. And And we were doing the same dumb stuff that we do today. You know, we were like building scripts for projects to solve a particular problem that if you squinted and looked at that problem, it looked very much like a whole other set of problems or class of problems that you solve on all your projects every day. But then we just like stick it in a folder on the server and like, and go on to the next project. The next project, we'd open up a blank piece of software and we'd start doing the whole thing all over again, even if it was like, and Bureau Happold does a lot of buildings that are, you know, kind of similar. Like for a while there, they were covering every canopy, every courtyard in glass. It was like, how many of these do you have to do before you like have a set of tools that like are the common capabilities that are required for doing this kind of work? But it was just never like, that was never the thought. You know, it was funny because we very rarely had conversations about the next level up. We had conversations about like, how do I get my center lines from Rhino into Revit as beams? Let's make a tool to do that. But the next level up, how do we think about framing? I get a complex piece of geometry. I need to frame it in one of a small number of ways that we typically frame things, either by projection or by some dynamic relaxation or some grid, or, you know, why don't we write those algorithms and then share those around the organization? And as it is today, the problem was Bureau Happold was a global organization. It had offices all over the world. People were calling me on the phone to write software, and then you'd send them these installers, and the installers wouldn't work, or their IT setup was borked in some way, so they couldn't install the things, or they couldn't get the newest version, or blah, 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 or what version of Rhino are you using? What version of this plugin are you using? Blah, blah, blah. You have this global organization, and you cannot effectively roll out anything that you've created. So that was a problem. And so that was where actually the Dynamo package manager came from. And we started the Dynamo project, and then we got some impetus sort of behind that thing inside Autodesk. One of the first projects that we worked on, and Peter Boyer, who's now at Hierarch, gets the credit for the initial version of the Dynamo package manager. We were like, we need a package management system because people need to be able to take the thing that they've created and share it with their organization first and foremost, be effective about scaling our expertise across our practice. But secondarily, they need to be able to distribute that thing to the world, you know? And package management systems were we were all affected by Sublime Text. You know, Sublime Text had come out and it had its like command palette thing where you could just go to and search like all the packages that were available in the world for Sublime Text. And this was like, you know, and I'm sure for software programmers at the time, it was like not a big deal, right? But like for us, thinking that like we could distribute these packages and people could use them. And I for some reason, I was on the Dynamo packages page the other day. I was just like curious. I went to Dynamo packages, and there's like a couple million downloads now up there, which is very heartening for me to think that people have like used and reused that stuff over and over again and have continued to contribute there. So unfortunately, a lot of the stuff is the same, right? Like a lot of the problems that Hypar is solving are trying to provide better solutions for the industry, which has not been given solutions to solve these problems. How do you work across how do you deploy your expertise across your global practice or share it with the world and build on top of stuff that other people have built effectively in the tools we have now? You don't. And I know that everybody out there is saying, well, there's food for Rhino and there's the Dynamo package manager and everything else. And that's true. They're both great ecosystems. The challenge is that they still don't really help expertise to scale inside of organizations. They'll help you do specific things like I'm going to use Ladybug and Honeybee and all the amazing tools created by the team over at Pollination Cloud to do daylight analysis, simulation, that kind of stuff. But does that really help you do that across the practice? Does it really help you to do that thing more effectively for your global customer base? So largely still solving a lot of the same problems.
Yeah, and like I got more into like software development in like last 1.5 years ago, and I could see so much smarter workflows in that industry compared to like what we have. And I was even exploring like yesterday GitHub workflows and like automate GitHub actions, and that is such a cool thing. And I was thinking, what if we do design iteration and have few options? any structural design code is being like had like auto run script of various design, and just push the GitHub and like it does for you.
That particular example is a fantastic example because, okay, so for everybody who's listening who doesn't know what Myra is talking about, GitHub, which is a large code repository system that's owned by Microsoft and is based on a technology called Git, made by Linus Torvalds, the founder of Linux. It's a place that we store all of our code. It's how we collaborate on code. And there's a couple of things to understand about how this model is so different than what we do in AEC. So just at the lowest level of Git, when you push changes, usually you push very small changes. When you're working in collaboration, you push a tiny little change, and then your collaborators can see that change. And you can even, GitHub is layered on top of that, the ability to like approve changes. You can see the changes that are coming in and you say, yes, I accept these changes. So just this idea of like highly iterative collaboration. And if you're thinking, well, I saved to central. No. You're thinking of something different. I don't mean like you save to central and all of your columns now run into all of your ducks and you've got to fish through this enormous model and find where things run into each other and everything else. I'm talking about like, I changed this one tiny little piece of code and it went in. And when it does, and this is the second layer, a set of automated tests run on your code. Mm-hmm. And those of you who are into code, you could go, for instance, the Elements library, which is one of our open source projects. And you could see we have hundreds of tests. And every time you push even the tiniest little change, an automated system goes and runs all these tests and validates essentially the health of your library. So when I started doing automated testing, it hit me like a hammer between the eyes. I was like, how is this not what we're doing in AEC? Mm-hmm. Like we have tests. We have, does this meet our environmental criteria? Does this meet our structural criteria? Does this meet our people flow criteria? We have all of these tests, but the problem is that the tests are human tests. Mm-hmm. Yes, they're mediated by software, but they're still like incredibly slow, oftentimes on the order of weeks. You change your design, the structural engineer has to go off and do work for a while. Bureau Apple prided itself on the fact that like it only took us 24 hours sometimes to return sort of design impact feedback on a change to a very complex piece of geometry on the structural side, because we had our tools just like wired in. But why should it even take 24 hours? Like these systems should be automated. So the systems that Myra is talking about with workflows and actions are further layerings on top of GitHub that enable you to have these very complicated, I shouldn't say complicated, complex workflows that run as an automated byproduct of your adding new code to your repository. So these are things like running tests. There are also things like packaging things up and deploying them. You can do all kinds of stuff. And again, I invite you all to go to some of our GitHub, our open source GitHub repositories. You can see all this stuff is wired up. Like we do all this stuff right now. It's how the Elements library gets built and everything else. And so, Myra, to your point, when we started Hypar, Anthony and I, Anthony Hauk, who's my co-founder, we started talking about one future use case for Hypar could simply be automated testing. We trended towards generative and generating geometry and stuff because there's a lot of those kinds of problems, like really interesting problems to solve in our domain. But there's an equal number, if not more, problems to solve that are just analytical in nature. It's like, I changed this thing about a design. Can you go off and run these tests? And the architecture for doing that kind of stuff just isn't available in the software we have now. Those of you who've been following the Dynamo project for a long time know that we wrote a thing years ago called the Revit test framework. The Revit test framework was unit testing originally for the Dynamo libraries on Revit. But it could be used for any kind of unit testing of your build-it model. But getting that thing to work in a software that was 100% not built to accept that kind of interaction, like I want to drive this software from the outside, opening it with journal files, doing this thing, testing the results, and reporting those back in some way, was an incredible lift. And I think they still use that system actually to test Dynamo. So that's these kind of systems like Hypar that are just like logic running in the cloud and can be run at any scale you could do that right now with hypar. You could attach it to a Revit model and say, run these checks. And I'm going to write these like tiny little tests that are very simple little pieces of code and deploy them to hypar as tests. And I want those things to run in an automated way when I make changes. So there's a huge opportunity out there for us in the sort of automated testing and kind of conformance space.
I see. Yeah. And definitely, like I really appreciate Hyper for all their open source aspect. Like Elements is totally open source, so it's rare to see such development. I want to pick your brain on like encoding institutional knowledge. So many times, if there are configurator or script, there are also, along with problem solving, there are like biasness and assumptions in that script. And one thing I like about libraries development and GitHub open source is like people can issue like issues or like problem and develop on top of it. And then it's like evolutionary. So how can we build an evolutionary configurator?
We are, I love that, evolutionary configurator. That is the way we talk about what we're doing. So Hypar's business right now is split into two parts. There's a subscription part, which is some of you who may have used Hypar have gotten a pleasant little message that says, you're reaching the limit of your free tier. Subscribe to Hypar now to keep executing. So that's our subscription tier. But then there's also a large amount of onboarding development that we do for our customers, because we've painted this vision of this new future. And it's like a superhighway, but you got to get people onto that superhighway, right? And the problem is, and the way this conversation usually goes down is, we love what you guys are doing. We really want to work on Hypar. We want to deploy our expertise in this way, scale it globally, execute it at scale. We don't have any developers. Can you help us? And so this is actually, unfortunately, this part of the business is the hardest part for us to scale. And this is one of our big challenges right now, because it means working very deeply with that customer to encode their expertise in a way that it can run on Hypar, and which we always say, this is not code that's specific to Hypar. This is just your logic encoded in a way against these open source libraries. You could take this thing and walk if you want. At some point you say, I don't like these Hypar guys, I don't want to work with them. You take that thing away, go turn it into a Revit plugin, go turn it into a Dynamo script, go turn it into whatever. It's just code. But this is what you need to do. You need to sit with the engineers, and I'll give you an example, a sort of an abstract example. We work with a number of building product manufacturers. People actually manufacture the stuff that hangs in the buildings, that holds the buildings up, that, the materials, the hard stuff inside buildings. And a lot of times for a building product manufacturer, they have a configuration process or a design process that they need to do in order to make the sale, in order to get you to buy their system of plumbing or their mechanical system or their lighting or their whatever cabling. They need to configure that system. And so what we do is we sit down with their internal sales engineers. It's usually a sales engineer. And that sales engineer's job is usually to talk to customer. Tell me about your project. Give me your Revit model. Give me whatever design assets you have. It might just be like PDFs or whatever. I'll design this thing for you. And it's a very human, very expensive, very slow kind of thing. And that company doesn't make any money until they sell you the end product of that whole thing. So for them, this ability to configure, price, and quote like in an instant, as opposed to telling their customer they got to wait for a week for me to do this thing, is incredibly valuable. So what we do is we go and we sit down with that sales engineer and we just unpack their brain. Okay, what is because the other interesting thing is we oftentimes are working with customers where we have no idea. I don't understand their system. I've never worked in this before. Like, you have to teach me how you do the thing. But that's where it's so amazing when you sit with somebody who does this. They can tell you, here's my algorithm. My algorithm starts, I do this, and then I do this, and then I do this, and then I do this. They will lay that whole algorithm out for you. And then what we do is we make a first pass version of that thing, and we stick it on Hypar and we run it. And we usually give the customer like a sandbox where they can go and play with just their function in a kind of like a dummy context. No even like real project data yet. Does it work? No. And let me tell you why it doesn't work. And this is to your point about GitHub. We say your code, which you now own, which represents these functions on hypar, is in this repository. We want you to hang a bunch of issues off this thing. I want you to take screenshots, put them in there, tell me why this thing doesn't work, tell me what this should look like, and help me to evolve this code. And then the next meeting we have with them, we show them V2. V2 has incorporated their last set of changes. And then the next meeting is V3. And we just basically asymptotically approach like the version of this thing that represents that encapsulates all the edge conditions and everything else that they run into in their process. So that's great for them. What's great for hypar is in the process of doing that, we shake out all this commonality. What we find, and this goes back to your question earlier about what did moving into software give you in terms of perspective of the industry. One of the things that it gave me is the opportunity to go into hundreds and hundreds of architecture firms and engineering firms all around the world and see that on some level, they were all solving the same problems, right? They were getting paid for their time to solve the same problems. They were building Grasshopper scripts that looked the same. They were building Dynamo scripts that looked the same. They weren't sharing any of that stuff because it was intellectual property, but they were all doing the same stuff. Well, similarly with our customers, they're not doing the same thing necessarily. They're selling a different product. But inside of each one of those products is a set of capabilities that should be pushed down into the platform. There's no reason if we figure out routing as one kind of set of problems for one customer, whether they're doing mechanical systems or whatever, or people flow, egress, that we should have to figure out routing again for a second customer. So we identify these opportunities to pull those things out, push them down into the platform. And what we like to say is that the platform gets thicker over time. And what the business logic that you need to write on top of that thing to deliver your value can get smaller and smaller and smaller because the rest of the stuff is just there. Another perfect example of this is gridding problems. You know, whether you're doing a facade or you're gridding out concrete formwork for pouring slabs, it's a set of problems. In fact, when Andrew Human joined us, one of the first utilities that he wrote, which is incredibly, he makes it more robust every week, is the capability in Elements called Grid 2D. That's all it does. It just makes like grids in 2D. and you'd be amazed how many like gridding problems there are out there. So what that enables us to do is not only thicken the platform, give more capabilities to all of our customers on hypar, it also enables us to accelerate this kind of onboarding. Because the next customer that comes in the door that has a problem that looks like gridding, we go to the tools that we've already built for the other customer. And usually in conversation with the customers, that is not their special sauce. The gridding problem is not their special sauce. Their special sauce is how their product works on top of that. So they usually say like, sure, I mean, I understand the value of pushing this down into your platform and distributing that. That's not, but we want to be able to protect that business, our business logic, use that for our business purposes. And we might not even want to share that with the whole platform. We might want to just like publish that thing to our global organization. And so hypar makes it possible to do that too.
I see. And like, I wanted to know your thoughts on like the awareness about like, or basic coding knowledge that should be there in the industry. Like, I personally feel like I was also following like one Twitter thread where there was AC tech company, and a lot of time in their first meetings, it goes into awareness, what is front end, what is like basic coding, rather than the product itself or the possible collaboration. And like either we could develop a no code approach, or either we could go like have programmers with domain experts and develop tools, but also that limits like scalability. Hyper team has a limited time and resources to approach companies to develop products. Like, what if you want to like do like independent exponential growth?
So this is definitely a challenge. And I was thinking last week, I'm always somehow party to these conversations where people are asking, like, should architects learn how to code? And I'm thinking to myself, finally, like, because I've been part of so many of these conversations, like, do other industries have this conversation? Like, I don't know the answer to that question, but I'm wondering if like, do physicists have this conversation? Or are they just like, no, we're getting back this like crazy data that's in all these formats that we need to like manipulate in some way? Of course, we're going to like learn how to write some code to do that. It's just like a tool of the trade. interestingly, that kind of ethos has not permeated AEC. I know there's many of you out there listening who are probably like, yes, it did. Hi, I'm right here. But and the computational designer is right. But when I say permeate, I mean like diffusely, right? Like everybody just has some layer of like, oh, the tool that I've been given by XYZ company doesn't do what I need to do, but it has this API. Let me go, write a script that does what I need it to do. And so going back to visual programming, which is the way that we've kind of like approached this for the last decade plus, it's great. I mean, obviously there are examples out there of Dynamo and Grasshopper doing incredible things, building incredible buildings. Incredible buildings have been built. So it works. Right up until it doesn't, for all the reasons that I was talking about earlier, and which you just mentioned, like scalability. I always include in our deck, I include when I'm talking about this, an image from Andreas Diekmann, who was one of the very earliest users of Dynamo. And Andreas was fantastic because I think at the time he was teaching at Aachen University, and he was teaching a BIM class, and he was using very early Dynamo. So it's an image with the original orange Dynamo nodes. And it's like a 500 node. It's this monster graph, and it's like zoomed way out, so you can't even tell what it's doing. And I always ask people, like, what do you think this graph is doing? And people in the audience will say like, oh, I think it's generating this like crazy geometry, or it's doing this, whatever. And I'm like, it's grading papers. And everybody's like, what are you talking about? Well, at the time, Andreas Diekmann was teaching a class. And Andreas, I apologize if you're listening and I get this a little bit wrong, but what I might remember, my recollection of you telling me the story is that you were teaching a class on BIM, and that model was there to grade people's models. Like it did this whole set of, I don't even know what the metrics were for grading people's models. And at the end, it output like a grade, And I was like, this is like a kind of a funny Rube Goldbergian sort of example of like visual programming and how we use this thing and how we kind of like all accept that things should be complicated in this way. And the thing is, we did make efforts inside, for instance, Dynamo, to sort of start to counteract this. So custom nodes were originally thought of as a way to like package up all your stuff and then distribute that custom node as like a method, like programmers do in a library. So you could use just that thing, and then you could embed those in themselves in And for a number of different reasons, custom nodes never quite got the love that they did. So packages just became like, you got this enormous script and the script did its thing. So scalability and fragility. The other thing is these visual programs, you go in there and you're not the person who wrote that thing. Good luck, So, so you have a real, that's a business liability. Right. I've actually seen practices like rebuild the whole same complex thing because somebody left. The person who built the thing before left. Nobody knows how to use it. Or when they use it in a certain way, it breaks and they can't remember, like the person who originally authored the script is like, oh, no, don't make that value 5 because the whole thing will blow up and all the nodes will turn red. That's a huge liability that I don't think like companies understand from an institutional standpoint. Like you've got all this incredibly fragile, non-scaling sort of expertise out there that you can't deploy globally because package management and installers and like all this stuff. So when we started Hypar, we looked at that problem and we said, we really challenged ourselves. And I joke with Andrew sometimes. I'm like, I have to sit on my hands to keep from writing another visual programming language because it's like an easy way to solve certain types of problems. But we challenged ourselves to make an interface that is at the level or simpler than Excel to use. We figured if people can use Excel, they should be able to use this thing. So if you go to Hypar today and you look at your workflow, it's basically like sliders and input fields and drop downs. And you'll notice that there's no graph. Although there is under the hood, we're doing all that stuff for you. We're calculating dependencies. We're executing things in the proper order. We're, putting together all the data in the way that you need to see it. But you don't have to worry about that. You don't have to manage that. And what we did was we kind of solidified what everybody already does in their visual programs, whereas they define an interface. And by an interface, I mean, in software, the interface is a sort of shape of data that comes in one end of your process and out the other end of the process. There's like two interfaces, right? Here's the interface to my upstream thing, and here's the interface to my downstream thing. So I take in some inputs and I create some outputs. Think of a structural system. The structural system needs to know some grids and some levels, and then it does its thing, and it outputs beams and columns, right? That's a very simple example of this. So we went up to the level of interface and we said hypar should be defined as this set of sort of functions that are the business logic that have these really well-defined interfaces. And the interfaces should be composed of schematic types. And that is where elements again comes in, because it's the thing that provides those kind of types. So in the example that I just gave before, the structural function just creates like beams and columns, and it gives those out. And downstream, if you wanted to make a structural connection generator, you would make a function that just assumed it was going to get beams and columns, and that it was going to output structural connections, or it was going to connection forces, or whatever you were designing for. and all of the tools in hypar kind of lead you on these paths to define those interfaces. So now we're talking in the same way that software engineers do about services talking to each other. And it's interesting because it maps very naturally to the way that we approach talking about how we're designing in the real world. When you as an architect work with your structural engineer, he says, okay, where's the top of slab? Where are these grid lines? You talk in interfaces all the time. You just don't like really think about it in that way. So all we're doing is solidifying that idea of, I'm going to present to the world an interface that needs to be fulfilled in order for me to do my business. But then hypar takes care of everything. If you've used hypar and you've dropped stuff into the workflow, it'll tell you like, sorry, can't do anything because I don't have levels. Can you give me some levels? And then you got to go and figure out a way to do levels. And because everything is again defined by like schemas, we can even do things like when you go into the search after you get that little message, all the stuff at the top of the search are things that create levels, because we know that's what you're kind of looking for. So we can give you all these affordances to do things more quickly, more easily, in a less fragile, more scalable, infinitely more deployable way, right? Because it all runs on the web. I hope that answered that question.
Yeah. I totally get you. And actually, while you were sharing that response, I was thinking like in software development, like they play a huge emphasis on documentation, the README file, writing comments on the code, or testing it, and like they have good amount of time spent on that. And from my experience, like in studio, like or other place, like before the deliverable, we're still making changes in Revit model or making the final presentation. So like testing and like doing checks on the model cleanliness or tightness is like way far beyond. Like we just don't have time to do it. So that's why like this, like when you mention about automated testing, I think it's so much needed.
Yeah, I think so. And on your point about documentation, that's the other thing that we noticed. And it goes back to the fragility conversations. The other thing you notice about everybody's very highly elevated practices around Dynamo or Grasshopper or other systems that they're using are always like, we use this group color to represent this. And we always put our inputs in a block that's called inputs far to the left. And like all this kind of rigmarole has like been added to those languages to give them the kind of structure and documentation that should just be there. I remember seeing Charlie Pertelli's script at KPF one time for doing a tower generation. And he made this thing that was like, it generated the whole tower, like right down to the handrails in the lobby. It was crazy. It was a crazy script. And he had like pictures in there with detailed notes and arrows pointing to things. And it was beautifully documented as well as it could be in Grasshopper. But that stuff, again, should just come for free. To take GitHub as another example, very early on, they said, put a readme.md file, Markdown, at the root of your repository. And when we serve up your repository's front page, we will show that Markdown. And it can have images, and it can have text, and it can have all this stuff. So we're actually starting to do that with hypar right now. There's a functionality that I don't know that we surface all that well to allow you to include Markdown documentation. So somebody coming into a workflow can see as a widget hanging in the view, here's the documentation with images and everything that you can do in Markdown, indicating what you can do with this graph. And I don't think we've actually even started to scratch the surface of what we should be doing there, because proper documentation is the thing that invites people. It's an invitation for you to use the software, right? And the best documentation is the best kind of invitation into using the software.
Yeah. And if I may suggest something, like one thing I find really useful when I'm trying new libraries, like if they have like step-by-step implementation procedure. So in case if hypar is integrating this, like if you have a GIF, okay, step one, click on here, do this.
So those of you, this is fantastic. I'm sorry, I don't mean to cut you off, but yeah, it leads very naturally into the types of not exactly documentation, but kind of like tourism. That's not the right word for it. Wizard-based step through gradual approach to introducing somebody to a complicated concept. So this idea that like, do this first, and then do this, and then do this. And actually, if you go to a lot of web interfaces now, you actually get a little endorphin rush, because once you do the things, you get like a little celebratory sort of like, poof, here's some confetti. Like you did it. Like you completed all 4 steps in filling out your healthcare survey. Congratulations. Well, that's a fantastic pattern though, because it does 2 things. It makes it very easy for you to take somebody who's never used this thing before and tell them exactly the things they need to do in order to make it do something worthwhile. And then the second thing is you reinforce everybody's need for like approval. Like, I want to know that I did something today. I've crossed this off my list. So those little sort of celebratory moments. So if you've gone into hypar lately in the workflow now, you'll see, even when the workflow is kind of collapsed and you're seeing the version that just like says the names of the functions on the left, you don't even see any inputs. If there's a required input inside there, the team designed this little bouncy indicator that's like, do this, make a polygon, And so like, if you click on that, the function opens up and it's very clear, like, oh, I need a polygon here. And you click on the button that says make polygon and you go and do the thing. And so that's our first version of that. But as we slowly migrate the workflow panel as it is away, so you never need to use that thing, even better affordances. So like, you should be able to create a workflow on hypar that if a user comes in and they've never experienced, they clicked on a link in Twitter because they saw a version of this workflow and it looked really cool and it's public. Okay, cool. I'm going to go use that. If it knows that you've never done that before, and again, this is the beauty of doing everything in the web and the cloud, right? We can know this. We can know you've never entered this workflow before. You need the first user experience. And the first user experience is go pick a location somewhere on the planet. Go do this, go do this. And it just steps you through that thing until you get something reasonable. It's not going to be exactly what you want, but of course, hypar then enables you to go and edit all that stuff. So yeah, I think we have, and frankly, I'm surprised that nobody has done this with like Grasshopper or Dynamo.
Yeah.
Like nobody said like, I'm going to slide you to the place in the graph where you're supposed to do something and tell you like, boink, 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 because they all have like libraries to do that. Like you could do that in Dynamo, but it's more like everybody was so proud of the practices that they developed around like wrangling Dynamo and Grasshopper that they just kind of institutionalized those instead.
Yeah. And also like transfer of those scripts, sometimes like there are like huge chances of error when during transition, or sometimes if you change something, but if you don't know what's going in the backend or like what algorithm, like there are potential mistakes you could also make with the script. And I wanted to know more about, like, recently you tweeted about a playground feature.
Elements playground. Okay, so yeah, we've been doing some experimentation. All of Elements is written in C# using .NET. It's a language that we've been using for a really long time. Because I started Elements, I got to choose the language, so I chose C#. And we also chose it because all of the desktop applications that people are using right now, if they have an API, you can use it via C#. It wasn't exactly the case with Python or JavaScript at the time that we started the project a couple of years ago. So, but that is just that choice is paying dividends. because what those of you who have followed in the computational space or in the programming space have seen is the massive amount of research and development that's been going into .NET, which underlies C#, in order to make it faster, stable, more stable, and work cross-platform, right? So our entire infrastructure, which runs on Linux microservices up in the cloud, is all C# stuff that's compiled to that architecture and runs incredibly fast. And so we just continues to pay dividends as a sort of a choice for us. Well, one of those dividends is that WebAssembly, which came onto the scene a couple of years ago and is the way that you can compile code into a format that can be executed at near native speeds in your browser. And you can compile a whole bunch of different languages that way. You can compile C, C++, C#. You can compile all these things in WebAssembly and then run them in your browser. Suddenly opened up this pathway for people who are making web applications like us to embed features in those web applications that weren't written in JavaScript or TypeScript, that were written in the language of whatever your programming library, your software libraries that you're using. So the Elements Playground that I tweeted about is actually a WebAssembly compiled scripting interface, which uses a couple of things. It uses Elements as the API to create stuff. It uses GLTF as the way that we serialize into 3D for visualization. And all of that stuff is compiled into WebAssembly and run in the browser. And to Microsoft's credit, it's pretty amazing what you can do. I mean, we are actually compiling C# code, emitting compilation errors and displaying those to the user, just like a proper development environment would. And then we're like actually executing the code at pretty fast speeds, generating GLTFs and visualizing them. So the way that we're thinking about using that in the future is, right now, if you're building a function on Hypar, you need to know something about software development. You need to pull down Visual Studio Code or Visual Studio, the free edition a lot of people use. You need to get the Hypar command line interface. You have to learn what a command line interface is. You have to do these things, which we try and make as easy as possible, but are still things to learn, and everybody's busy. So the thought has always been, we need to reduce the amount of friction for you to create something valuable on Hypar through code. And so one way to do that would be just to move the development experience into the same environment as Hypar. So in the future, you might imagine, like, I have this workflow. It's got all these nodes that I've pulled from the community to start building my thing, but I really need a function that does this one thing, you know? It should be super easy for you to say, plus new function, name it, description, here's code. And like, here's my input interface, and it previews the input interface for you. I'm naming my inputs. It shows you there's going to be a slider. This one's going to be a color picker. This is going to be a location thing. And then in that code, you say input.location, and it's actually like clear to the user that they're pulling the location out of that input that the user will have filled that in for. And then you say publish, and it just publishes it to Hypar. And it's private at first, like all Hypar functions are. But then at some point you're like, you know what, this is really useful. I think this would be useful to the community. So you just go over there and say, I want to make this public. And now it's available to everyone, everywhere around the world, running in Hypar. And there were no installers. There were no like getting your IT people to unlock that thing. There's no versioning problems or anything else. We're taking care of all that stuff for you. So so that is one small piece of technology that is on this ramp towards just making it easier and faster for you to create functions.
I see. Yeah. And like recently I have been like doing more experiment with GraphQL, and they have like a good playground explorer to query APIs, like other is like this. So is Hypar planning to release API at some point in future?
Man, you and everybody else have asked us this question. So you really push back on this question. And the reason is, I love the idea of everything that people are building and all of the capabilities that Hypar exposes in terms of orchestrating these functions and creating this architectural compute cloud. I love the idea of giving people an API to be able to just call that thing. But when you dig into what people actually want, they're actually making feature requests for the Hypar web application. They're like, well, I want this because you guys don't have this input that does this thing. we're like, okay, well, why don't we just add that input for you?
Yeah.
One of the theses that we had at the beginning of Hypar was that we should make it super easy for you to get to your value add. And I don't think that your value add, if you're an architect or an engineer or somebody working in real estate, is building a 3D viewer or figuring out where you're going to do that compute or getting the bits onto your user's device or all of that software stuff. I don't think that's your value add. So we want to be very careful if we are going to open up an API to make sure that we're doing it for a reason that is like fully outside the remit of what we see Hypar's value add, and allow you to like go off and do something amazing with it, and not just like a thinly veiled, well, I want to do it because I want to hook it up to Grasshopper because I want to do this input or whatever. You know, we have Grasshopper nodes. We have a whole like Grasshopper like runtime. You can just drop your Grasshopper thing on there as a function and run it. And oftentimes when you have that conversation, people are like, oh, I didn't even realize you had that. Like maybe I should go and use that. And that's just a failure on our part to tell the story as completely as we should. So please, if you're out there thinking like, I think I have a use case for the API, join the Discord and let us know, because I really want to find those use cases that are something that we shouldn't be solving to make the whole problem easier for you, to provide a better stack for you to build on. I'm sure those problems are out there. And I suspect that at some point in the future, we'll have an API.
Got it. And I must say, like, I'm super, super impressed with all the developments and the way Hypar works. Like, there are so many things which you have developed which are cutting edge, but on the interface, it's a very smooth experience. And based on your journey, like, I'm very interested to know. So you have played different roles. You started with like development, and then iOS, Dynamo, and this. And I am guessing you don't go to Barnes and Noble to read programming books these days. So what's your recipe to like learn things very quick in very short period of time?
I'm going to give you not the answer you expected to this question. No, I don't go to Barnes and Noble and read programming books anymore. I listen to like management podcasts and how I built this. And like, because my challenge is right now, so I have two challenges. One is making this business successful, which, as you can imagine, being the first like tool of our kind in literally a generation to enter into the market and to teach people like, here's the new way of how we're going to be doing architectural compute in the future, and let us show you why this is valuable to you and your organization, and then building a business around that thing is a huge challenge. So that's my number one challenge. But secondary to that is trying to pull myself out of the code. We are so fortunate at Hypar to have an amazing team. All the stuff that I've talked about today was not built by me. I built version 0.0001 of the thing, and almost all of that has been ripped out root and branch and replaced with smarter, faster, better stuff written by this team. So the bigger challenge for me is getting out of the code, because I love doing that, and focusing where I should be, higher up in the funnel, as it were. I will say though, on the programming side, there's people out there thinking like, okay, what am I going to take out of all this stuff that Ian's talked about today? And what am I going to take away? You're so much better every day. You're better off learning stuff than you were the day before, because the pace of information being out there, the development in programming languages and platforms and everything else for you to learn and deploy your skills is incredible. Like, I had to go to the bookstore back in the day because that's the only way. And then Stack Overflow came out and it was like, whoa, forget the bookstore. I'm just going to like copy and paste out of Stack Overflow. But just the resources out there now. But there were no like webinars. There were no like online learning series, video tutorials, any of that stuff. That stuff is all out there now. Grab a book on Python or just go like on a little Python programming tutorial. And the most pleasing thing for me about Dynamo is that I've had people come up to me over the years and say, you know what, I got into coding because Dynamo couldn't do what I needed it to do. So I opened up a Python node and actually hacked the system to do what I needed to do. But now I write like standalone software because it's just like better for my organization or whatever. So I hope that we can make some choices in hypar that facilitates that same kind of like fascination and challenges people to push outside the boundaries, and that people come up to me in the near future and say like, yeah, well, I learned to write my own functions because you guys didn't have a thing that did what I needed it to do. And so, but I read your docs and they're great. And I followed one of Andrew's tutorials and it was fantastic. And I watched Eric's video from a couple months ago and I learned how to do this, and like just putting out content that makes it easier for people to do that.
I see. And that's quite satisfactory feedback to know. And actually, I wanted to know something, but I'll reframe the question. Like, how do you filter out the noise?
I don't. I mean, I'm terrible at that. You mean like filter out the, like, you know, the problem is, okay, here's the problem. We're a VC-backed company, and we love our investors. Especially the team at Building Ventures has been incredible in the foundational sort of years of hypar, which I actually kind of still think we're in the foundational years of hypar. Just in terms of like getting us out there and opening doors and creating conversations and introducing us to other people who might be interested in riding on this crazy train with us. But the challenge is when you're VC backed, you know, there's a lot of, you know, Twitter is all about like, oh, I made this app and immediately scaled to like 1 million users. And I've like just raised $100 million. And then on top of that, there's the fact that we're in this like super, super flush capital environment right now where everybody's like, I just raised $100 million for my app that's for taking pictures of bananas or whatever. and that's like the worst kind of noise. Like the thing that we need to do is recognize that AEC is going to be a grind. Like this thing that we're building is a marathon. It's not a sprint. And we're going to have to just fight from one company to the next company to the next company and demonstrate how this thing is the future, because we're 100% certain that it is. And the challenge is just, as you say, to filter out the noise and just be mindful that we're able to recognize that future. But I'll say, I mean, personally, I'm not very good at it, but hopefully I'm good at it for the team. Cause like my job is kind of to provide this umbrella so that kind of stuff can rain out of the sky and bounce off and not hit everybody else.
I see. Like, to be honest, like I grew up in a generation where like being entrepreneur, like is cool. Like it's startup is amazing. So like, what are some, aspect of AC startup which no one talks about and which are like rough?
Well, some aspects that nobody talks about. Well, I mean, some of them are just aspects that are aspects of any startup. It's hard. Like it's hard to leave the comfortable thing that you're doing now and suggest that there's a better way of doing things. I think Anthony and I, when we started hypar, we were both kind of an age. We're also like a little bit older for founders. You know, we were both just of an age that we'd watched the same time loop repeat in AEC so many times that we were like, we cannot leave our careers with this going on. You know, there's just got to be better. And just everybody complaining that Revit doesn't do this and Revit doesn't do that. And I mean, Matt Campbell, our CTO, joined us from Google. And I'm like, I pinch myself every day that we managed to entice him away from Google. But one of the first things he said to us was like, I've been away. He was an original Revit developer on the Revit team inside Autodesk. That's where I first met him. And he said, I've been away for 5 years now and nothing in AEC has changed. Oh. So when you ask about the thing that people don't talk about the fact that like you are going to be trying to win the hearts and minds and change people's opinions about how this industry should work, who have been using the same set of tools for 20 years, you know? So those switching costs for them are real. So not only are you painting a new vision of the future for them, they're also saying, look, I got 1,000 people in this firm spread across 10 offices around the world. And you're telling me that like the future looks like this. So again, building those on-ramps is going to be a hugely challenging thing. And especially because what we're doing at hypar challenges at some fundamental level, like what we're doing as people who build things. Like if your value isn't as much anymore in the hours of time that you sell based on your expertise, and some of that can be externalized into services that run at scale and they run when you're not awake and they can be accessed by somebody on the other side of the planet for very low cost, what does that do to our profession? You know, and I honestly believe that the architecture profession, the engineering professions, they'll figure it out. You know, like super smart people doing super smart things, they'll figure out ways to optimize on top of these new systems, but getting them comfortable with the fact that those new systems are going to be there and they will be the way they're working in the next 10 years is a challenge, you know? So I would say to anybody who's starting a startup in AEC and you come out swinging, you know, if you're watching this podcast and you're like a tech person who's coming to AEC, and I see a lot of these, you know, I came from tech. I had a successful exit with this other startup that did blah, 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 blah. And I tried to get the pattern is usually, I tried to get an addition built on my house. And I noticed that AEC is so screwed up. So we're going to fix it with technology. And then they come and they run straight into the buzzsaw of like the complexity of building things that starts with a muddy hole in the ground and ends with a building. You know, humility is probably the thing that every AEC founder needs the most.
Yeah, that's a great piece of advice. And I have seen like a lot of pitch where construction is 1.5 trillion industry. This is a big market. We have this technology to revolutionize this aspect, but it's also very complex and complicated once you enter the field and know.
Yeah, it's a challenging conversation. You know, everybody says, well, it's a $12 trillion global market. And if I could only get 1% of 1% of that, like it would be a massive business. Okay, what is your software going to do that? And how, when everybody thinks that everything under the sun can be done on top of Revit, are you going to convince 100,000 people to come and use your software? Tell me that story. You know, that's the challenge for all of us every day, is like figuring that out.
Yeah. And I wanted to know the business aspect of it. Like I was interviewing Clifton the other day, and he mentioned a point where, if you are running like bootstrapping your startup, many times when you're hiring, it's a tough decision because you have some savings, but you could hire for a few months. You can't give that guarantee to a new employee. And they took funding so that they could have like a longer leeway to like for hiring expansion. So what has been like from an outsider, like how have you figured out the financial model and like fundraising model?
So I think our business is actually quite similar to TestFit, and my background, because I've had an opportunity to sit with Clifton and talk about this, is actually similar to Clifton's as well. Clifton comes from a family business. I come from a family business background. We watched businesses we were kind of like brought into business as like we were growing up, and that by no means that I know what the hell I'm doing, but it just means that we were familiar with the idea that you like don't spend more than you make. Because these were not like VC backed, you know. So I think there's a certain, for me especially, there's a certain level of discomfort, which is a natural discomfort and a worthwhile in many ways discomfort with spending more than you make. But you have to do that to get to a higher orbit. The thing is that right now we're in this very, very low Earth orbit with all of our tools, and we've just been spinning around in this very low Earth orbit, and to boost to the next level is gonna cost money, because, you know, in order to get the talent and everything else to build that thing, you're gonna have to fight those people away from Apple and Google and, you know, Autodesk and big comfortable jobs, you know, where people have stock options and 401ks and all this stuff. And so it just requires capital. I wish I could think, you know, there are probably great examples out there of small AEC startups that have started and focused on a very narrow thing and said, we're going to sell this thing. And they built like, you know, a long-term sort of scalable business. I'm sure those are out there. But I think Clifton had the realization at one point, the same that we did, that was like, look, if we want to build a team that's capable of fulfilling this vision, it's going to require fuel. And so then the challenge is just managing your runway. And I would say the amount that the hypar team has built in the last 2 years is incredible, given the low amount of capital that we've raised. We are the most sort of capital efficient organization that I can think of. We've always been a distributed company. We don't have office space or anything else. So we've been incredibly capital efficient. I do think to get us to the next level in terms of, just getting the word out, marketing, outreach, finding those early partners to really help us demonstrate the success of the platform is going to require another boost, because even once you start to recognize things like our product Hyparspace that are really starting to get traction, that people really want to use and will come to you for organically, and will share, like, oh my God, I'm using this thing. I used to take 10 days to do this. Now it takes me 2 hours to do this. Like, even once you get there, to start scaling that just takes long enough that you're going to burn through, a certain amount of capital. And then there's, finding right pricing things for people, oh, I want to use Hyparspace, but I only have this office with 5 people in it, and I don't want to be on this subscription tier, but I think this is too much, like, So you're just kind of, you're doing that for a long time. And that experimentation, finding that fit takes capital as well,
I see. And like, I must say, like, including myself, and I see a lot of people who deeply resonate with the vision of Hypar and really believe in the team and what you guys are building. And that's what I foresee in the Discord too. So in case you are doing crowdfunding, you have a good amount of people to invest to.
Well, I appreciate that. And I will say in our last small round that we did, the Spatial Syndicate headed by Kat Dove came in and actually invested in us. And, if there's something that just like makes my heart swell with pride, it's that this syndicate full of people in our industry who were not making big investments, they're making small investments, but they chose to invest in us. That is a hugely important thing for us. In terms of making sure that this thing is successful over the long run. And so I don't know if we'll do any more sort of syndicates like that in the future, because things tend to get more serious as rounds go on. But I'll reach out.
Yeah. And what has been the lowest point in the whole Hypar development journey?
The lowest point? That's a great question. And I don't think every let's call it a minima is a local minima. There's no bottoming out. There's just like, you get to a place and you realize. I'll give you an example, and this is and I think if you were to go back and ask me that same question 6 months from now or a year from now, the answer will be completely different, I think, and even the answer around this specific feature. But when Andrew Human joined the team, we were like, this guy is at the pinnacle of the Grasshopper community. We're going to use those skills. Let's make a Grasshopper integration so people can just drag and drop their Grasshopper graphs onto Hypar and use them as functions. It seemed like in terms of building on-ramps, that was a no-brainer, right? Like, everybody we know is using Grasshopper. Like, and Andrew built this amazing pipeline to do that. It's like scary how magical this thing is. And it just didn't get the use that we thought it would. Now, part of that is because we haven't done the legwork to get it out there. We haven't gone into firms and said, like, why are you not using this? Is it too hard? Is it just not the way you want to deploy things? Do you not even know what Hypar is? There's legwork there that needs to be done. We naively assumed that everything we did on the platform, including Grasshopper integration, including the ability to do similarly an Excel workbook, just drag and drop that onto Hypar, that those things would just organically grow because people already had those assets. But what you learn very quickly is nothing happens like immediately. Like, you got to figure out why it's not getting traction, and you have to. So the local minimums right now are just like these bets that we made in those kind of on-ramp technologies haven't paid off to the scale that we thought they would. Why is that? There's work to be done there to figure out the answer. But again, they're just local minima because there's an answer out there. And the answer might be, you know what? You guys have presented this whole new universe. I don't want my Excel to dirty up this new version of the future. Like, I just didn't think that was compatible. Like, give me a connection to Airtable, or give me a connection to whatever, like some other API that's out there because I'm going to version 2.0 of my firm. That's why I didn't use it, but we haven't even gathered that feedback. So it's all just local minimum.
Yeah. And like, I was just thinking about, like, there are sometimes also like network effect and some pivotal point about a technological adoption. So after a point, sometimes if everyone in the community is buzzing with a product, like other people feel compelled to like join or test out. So we
are making bets there, and I think those are long-term bets. So one of those is, how difficult is it right now to share a Revit model? I just built this thing in Revit. I want to share it with you. You're in another office, you work someplace else. Like, how do I do that? I send you an email with a link to a Dropbox or a BIM 360 docs thing. You got to log in, get an account for that thing. You got to download this Revit model. Oops, wrong version of Revit. Get a new version of Revit. Like, several hours later, I've got access to this file. What you will notice on social media is that we post a lot of links to hypar workflows. You get a nice little preview of the image of the actual workflow, if it's public. If not, you see just our logo. And in the future, those previews will be richer and richer and richer. But if you click on that link, you are in the workflow. You might have to sign up for Hypar. If you've never signed up for Hypar before, you're in the workflow, but we're working on ways to even get it so that you don't have to do that. Like, you can just be in experiencing the thing. And that is what the web enables, right? And that's where you get virality. You get virality when the friction for somebody to share something with somebody else and for that person to become a user as well just drops to essentially nothing. When somebody shares a Calendly link with me and I go to Calendly and I have, obviously I can like book a meeting with this person, but I can also just like become a Calendly user because it's so stupid simple to do that. Calendly blows up. We don't have anything like that in AEC right now. And so we're making all kinds of little bets about how to reduce that friction.
That's a great example. And when I interviewed Andrew, he mentioned like I think in AU University, he met you and you presented Hypar prototype on your iPad to see how it works. And he was very
that's another one of these long-term bets, right? Is like, the mission of Hypar is to deliver the world's building expertise to realize better buildings. And when we talk about delivery, we like to talk about anyone, anywhere, on any device. There's a huge number of people all over the planet who would derive great benefit from access to the kind of building expertise that's on Hypar, that are going to be using a secondary market cell phone or a secondary market or tertiary market iPad, because they just got an internet connection, and unfortunately, a lot of people read this as like tech bros think that, technology is going to solve everything for the developing world and everything else. And okay, maybe there's a bit of that in there, but I honestly believe personally also that this idea that we're all going to be sitting with these space heater supercomputers under our desk and 4 monitors in the future is not going to be the way that people design. People are going to have a 17-inch slab of glass and be riding on a train someplace and be connected to a cell network and want to be able to design things and want to be able to take advantage of almost infinite compute in the cloud because they don't have to do it on that device, right? So mobile is also like a bet for us, but just because we're a small team, if you go to our mobile site right now, like there's a lot of stuff that still needs to be developed, and because mobile is very different from desktop, so touch modalities and everything else. And I'm hoping that as the team grows, we can put some more focus there as well.
I see. And I wanted to know, like, when you were, let's say, brainstorming ideas with Anthony or initial Hypar vision, and you had a roadmap and what Hypar is now, like, what were some pivotal moments or what were like some things you had to switch?
Well, when Hypar first started, you could only execute one function at a time. Like so functions had to do everything, which violated the whole idea of a function being like a thing that does one thing really well. and has a very well-defined interface. So when Matt joined us in 2019, one of the first things that he built was the orchestration system that now handles the compute graph, as it were. And so that was a hugely momentous thing, because now we could say, like, yeah, your functions don't have to build the whole world. They can build just the tiniest little thing, and then they'll be executed together. And then over time, the next kind of big waypoint was when customers started to say to us, like, and we knew this was going to come because of our experience with Dynamo and Grasshopper. Customers started to say to us, like, in this one particular instance, I don't want what the algorithm created for me. I want to reach in there and change that thing, move it around. But I want it to remember, so the next time it regenerates everything automatically, it leaves my changes in place. And so the team built the framework, which we now talk about as overrides, which enables you to do that. And this is, people probably don't sort of like contextualize how big a deal this is. But if you've ever worked in Dynamo in Revit, and you've like moved a beam that Dynamo placed and then had that beam go whoop, back into place because Dynamo owns that beam, and then you have to bake the thing and like disconnect it from Dynamo and do all this stuff. It's not the world that real world design works, right? The magic of real world design with the sort of augmentation that we do is that you're going to do something and a whole bunch of stuff is going to happen automatically. And in 99% of the cases, the automatic thing is right. But in that 1% of cases, like, you want to reach in there and make a change. And so when we added overrides, a whole bunch of new possibilities blew up. It basically opened a whole new, when I talk about augmentation, the ability to not only do the generative stuff, but then also reach in there and do the human stuff, make human choices, because the algorithms cannot be 100% correct. And so that is now going to be an incredibly rich venue of research. I mean, Andrew Human has this unnerving habit of posting demos on the weekend. So everybody like waits for his demos to drop in our Slack channel. And the one that he posted last week was the ability to just grab things and move them around like a proper 3D environment. Like all the 3D environments we use, you have a transform control and you can move things along axes, spin them, scale them. Well, we didn't have that because everything was generated by the functions. But we developed that on top of this overrides technology. So now you can grab any piece of furniture that's automatically deployed by a space layout algorithm and move it and have the system remember those choices. So that's another like huge thing for us. And another one that I'll mention, we haven't gone public with it yet, but I think is going to be huge is multiplayer. So all of our environments right now that we design in as architects and engineers are siloed single player environments. And the best you get is safe to central. It's crazy because every other piece of software we use now has some idea of like, we're in this document working together. And of course the vision of hypar is buildings generated together. Right. So if we're missing the together piece, we're missing a pretty important part of the vision. So the first manifestation of multiplayer mode is actually going to be single player or presentation mode, what we call presentation mode, where you can invite people to join a session where you're designing and they are seeing in real time in their version of hypar the actual model. So they can like turn things on and off. They can navigate through the model and everything else. But they're actually watching you to present. And then we're going to follow on that very quickly with multiplayer mode, where you're actually both in there making changes at the same time. And I'm sure everybody out there is thinking like, that'll never work. I don't want to design like that. We're having those same conversations inside hypar, right? and what that is going to result in is a version of this thing that is the best version of the thing for building buildings. We don't want the Google Docs like, I type 2 words in a sentence, you type the rest. Like it's something less granular than that. But we'll only get there by figuring it out. We honestly believe that people need collaborative experiences for design. So,
yeah, I remember, I think either you or Chuck mentioned in one of your live stream about potential multiplayer, like
oh, that's right. We did have, we have talked about it before. I think we showed, and Chuck on our team is building that whole thing, and it is not easy what he's doing. I mean, Chuck is doing an incredible job, because imagine with all the state that you can change in hypar, the complexity of these workflows, like making sure that synchronizes. It's the same problem, built in a slightly different way, but it's the same problem that, massive multiplayer games have, state management. How do I get your version of the world and this version of the world over here to sync up and look the same when people are actively interacting with the thing and changing it in all the ways that they can? It's a challenging problem.
Yeah. And I wanted to know your thoughts on this. So Daniel Davis talked about the fat middle in Speckle, and it was a great thing he touched upon. So what are your thoughts on this? And is there anything on the roadmap for hypar to cater?
Our whole roadmap is fat middle. Well, I shouldn't say our whole roadmap. Our whole customer base right now is fat middle. So those of you who are listening, he references this Daniel Davis article, and then later Evan Troxel did a podcast where he brought Daniel Davis on, where you might have seen Daniel talk about this at the Speckle conference. And he talks about how the interesting new technologies are going to emerge in this sort of fat middle of buildings. And he uses test fit as one example. And by that, he means, we talk about it as commodity architecture, whatever that means. It means not architecture with a capital A. This is not Zaha buildings. This is not Foster buildings. This is not Gehry buildings. This is buildings that you see when you're driving down the highway at 80 miles per hour that are logistical buildings and that kind of stuff. That's the fat middle. And I 100% agree with him that this is where innovation is going to start to take hold, because so much of what is done in those types of architecture is algorithmic. So much of it can be deployed in an algorithmic way. But the thing is, and I might be alone in this, I'm super excited by that. Other architects might not get excited by the idea of doing these kinds of buildings, but I think we are in this transformative moment in AEC. And again, like I said, we're getting the first new tools to do this stuff that we've had in a generation. And we should look past the fact that they're working on buildings that aren't what you think of as architecture with a capital A, and look at the fact that these technologies exist. They're only going to get better, faster, more powerful. And as they do, they're going to move super quickly out to the edges of that curve that Daniel describes. They're going to move out of the fat middle and out to, because the thing that I always tell when I visited people in offices, when I tell them about hypar, I'm like, look, take all the ceilings off here and all the walls off here. And you know what you have behind there? All the systems look the same. If you're in a Zaha building, or you're in your doctor's office here over on the Wilshire corridor in LA, what's inside those walls looks the same. And it makes up a huge proportion of the overall mass of the building. Why don't we figure out how to automate all that stuff? Because also, by the way, that's not stuff that people want to do by hand. Nobody wants to lay out the sprinkler system by hand. Nobody wants to, figure out where all the egress and exit signs should go, by hand, or run the low voltage cabling by hand, or generate the structural, beam layout by hand. There's so much opportunity for automation that thick middle is very, very rich. And so you're just going to see tons of people. I would like to think that you're going to see tons of AEC kind of attacking problems in that area.
So we will see many workflows there.
Yeah. I mean, like I said, our customers right now are unabashedly fat, thick middle kind of customers, and they're big companies, because of it.
Mm-hmm. Yeah. And is there any idea or feature you wish you want to work if you had unlimited time and resources?
It's not one feature. If I had unlimited time and resources, it's about the experience. We are right now building the sort of user experience and the UI just as we go on an ad hoc kind of basis. A user asks for this feature, we put it in there, but we don't have the resources to invest in oftentimes a really longer term study of how that thing should be. And I feel like half of the things that are in our UI could go away, through an act of sort of design simplification. But we're moving so quickly to satisfy customer requests that oftentimes design, and you've probably heard this a zillion ways, and a zillion other people who are smarter than I am who have said design is as much the act of taking things away as it is the act of adding. Adding stuff is easy. We have this incredibly powerful team that can add stuff really quickly. But when a feature doesn't land, or a feature isn't necessary, or a feature isn't working, or people aren't grasping what it does, taking it away or changing it in some way is an expensive thinking process. So really, I don't have like a specific feature. No, that's not true. So I want to do a bunch of this sort of reductive kind of stuff around the user experience and get just right down to the core of what we should be doing. But then I also want to, at once I want to focus on hypar space. It's this product we have out there. But at the same time, I want to have Solr analysis on the platform. I want to have structural analysis on the platform. All these things that we've done in these kind of janky workflows over time, I want to demonstrate that all those things are possible and that we can make these interfaces to those things and do what where we started this conversation, which was around that sort of automated, like if you could generate the structure and the facade and do the layout, and at the same time and asynchronously be doing a structural analysis that tells you, like, you just change this parameter, the floor to floor height. So I'm going to have to design, deeper beams here, and that affects the location of your mechanical system, and do that kind of automated stuff, which is possible in a system like hypar. That's where I want to go. The challenge is, as a small team, you got to focus.
Yeah.
You can't just go off in a zillion different directions. You got to like pick a couple and go very quickly in that direction.
Yeah. And like, I also like the startup mentality is like, try new things, like fail fast, move on, and build new things. So, and
yeah, that is, I will say, just towards that, Matt Campbell, who leads the engineering team as the CTO, has a fantastic way of enforcing exactly that. We're going to launch this version of a feature. It's not the full thing. It's not the full vision. It's the thing that we're going to start getting feedback on. And then we're going to iterate. So the team is fantastic about, putting stuff out there and then just making it better every single day, little by little.
I see. And I was just thinking about, like, when you were talking about simplification, like Apple does that very well, and their UI and experience is amazing. And the product
I think people underestimate how difficult it is. They underestimate really how difficult making the complexity of what we do. I mean, you're trying to describe to somebody how to generate a building. Like that's a fundamentally complex thing. How do you make that simple enough that, like I said, anybody who can use Excel now can do that, or even simpler? That's a challenge.
Yeah. And I was thinking, like you mentioned when you made your first iOS app about like integrating game engine into it. So are we gonna see some gamified approach on hypar or some?
We talk about this all the time. I think there's fantastic opportunities for gamification, which we should separate from game engines as a technology. We don't use a game engine. Everything that we've built in hypar is we don't use a game engine. But there are opportunities for gamification, that is making the interface something that gives you those little sort of endorphin rushes, And there are things like goal-based design. One thing about hypar right now is that it doesn't really do goal-based design. It will tell you the outcome of your structural analysis. It'll say, here's how much the building weighs that you just generated. But you could do a whole thing around, like, I want to see if I can make a building that only weighs this much. And through subtle sort of changes in the interface, you could make this sort of goal-based design where somebody gets like a huge celebratory moment when they actually achieve that thing. And then when you add on top of that the multiplayer aspect of it, you get people starting to think about, like, well, okay, wait, what if we did it? So you're going to start to see some of this stuff in formats that don't look like gamification. And one of those, one of our customers said to us, this is really cool that this thing does all this stuff and all these conditions. But what I want it to tell me at the end is where it couldn't algorithmically figure out exactly what I wanted. And I want it to give me a little exclamation point that shows me that on the model. And then I want to go to that location using overrides. I want to like fix it. how using my human brain to fix the thing. And then I want that exclamation point to go away. I want to solve that issue. They were asking us to basically make it so that they could burn down issues in the model. And I grasped onto that. I was like, absolutely. And you know what? When you get to the end of that, you're going to get like a little hooray, like you did it. Like maybe not hooray, like congratulations. You burned down like all the issues. The model is clean, as it were. Because, and again, to go back to your thing about testing, like in testing, you get all green, and then you get one test that fails and it turns red and you're like, yeah. And then you want to like, you really want to go and fix that failing test, like figure out what's wrong with it. So I think we could go the same place in buildings and get people thinking about like the healthiness of their building in whatever way they measure that, you know, and doing a kind of a goal-based design.
That's quite interesting. And I was also thinking, what if at the end of that game, you say you saved this many trees and this is the carbon credits you.
I use the specific example of the weight of the building because this morning there's going to be a tweet that announces that we've kind of partnered with SkyCiv to offer structural analysis on Hypar. It's a fantastic Australian company who does structural analysis in the cloud. And I was surprised to see that their example workflow, which you'll be able to just click on a thing in the tweet and go to, the outputs to that are embodied carbon in tons, the weight of the building, the price of the building, everything else. So there's these like 3 metrics that they obviously thought were important to structural engineers, one of which is an environmental an impact metric, one of which is a structural metric, and one of which is a cost metric. And you should be able to sort of like go towards any one of those things. They also have a thing in there that's like thumbs up, thumbs down. Does the design pass or does it fail just based on, so I love that kind of, our interface doesn't really support it right now. Like all that stuff is in there and you can see it and think about it in that way, but it doesn't give you the feedback, All
right. I'm going to wrap up this interview. It's a great conversation and I just lost track of time, but I have a few rapid fire questions and you'll have only maybe like 5 to 10 seconds to answer it. And you got to keep it brief.
5 to 10 seconds. That's going to be hard for me. Okay, I'll try. I'll do my best.
Okay. Which city is in your travel bucket list?
Which cities are in my travel bucket list? I would love to go to Buenos Aires. I haven't done a lot of time in South America. I would love to go to Moscow. I've never been to Russia. And I would love to go back to Tokyo because I haven't spent enough time there.
Okay. What's your favorite open source library?
Elements. But that's our library. I mean, it's my favorite.
Other than Elements, go.
Other than Elements, my favorite open source library. Well, you got to give props to James King and the Newtonsoft JSON parsing library for C#. We use it for all our C# stuff, and have been using it for a very long time. And I don't know. We've always tried to keep the number of dependencies and elements so low. I can't even like think of other open source libraries. Maybe I'll come back to it.
Any technical or business book which made a big impact in your life?
Any technical or business book which made a big impact in my life? Well, I mentioned earlier Heino Engel's Trog Systeme, which you can still get on Amazon. Sorry, it's a little bit hard to see. Yeah. Fantastic book for those of you who are structural engineering minded. I'm trying to think on the business side. Oh God, you've put me on the spot and I can't remember the names of any of my books. Maybe we should put some stuff in the show notes.
Okay. Yeah, you have a good library I could see.
Well, the other one, it's funny because this one, 3D math. So back to my Barnes and Noble day, and actually this still has like the Barnes and Noble original receipt in it. This was the book that I bought when I was like, what is it? What are vectors? What are matrices? Whatever. So Fletcher Dunn and Ian Parberry's 3D math primer for graphics and game development. This thing is so dog-eared, it's basically like falling apart. But I've been using this for years and years.
It looks pretty new.
And then, and right next to it is The Pragmatic Programmer, which is a series of books that was written by this guy all about like programming. That's actually where I learned about like automated testing It's a fantastic book.
I see. Do you miss designing?
So I never really designed, because I went out to Bureau Happel and started working right away. The design was always done by the architects, and then the structural design was done by the engineers. And I was just there to help them automate and facilitate that kind of stuff. So, I don't, aside from my projects here at home and stuff, I don't do a lot of design, but I do a lot of sketching, because sketching is the way that I kind of like figure stuff out. So no, I guess the answer to your question would be no, I don't miss design.
Maybe I should have asked, do you miss sculpting or doing sculptural projects?
Yeah, I do. And the team has seen, we present on Fridays. We have like a happy hour thing where we rotate through everybody and we present on something that is close to us, and I presented on marble carving in one of those things. And I've always thought like one of these days, and I was just in San Francisco this last week and I went to the SF MoMA, and they have a great Isamu Noguchi piece there, which is one of his kind of like hanging things, and it's installed right in a gallery next to the Calder sculptures, and it's super amazing to think that these guys were kind of doing these things at around the same time. And I've always thought like I'm going to be like Isamu Noguchi. I have a book on Isamu Noguchi where they show his garden when he was like older. He was like super old guy, and he was carving these enormous pieces of black granite, and he had just this like life sort of surrounded by these half-done sculptures. I feel like that's going to be my retirement one day.
I see. What is one thing that excites you to wake up every day?
This community. I mean, I honestly, as much as like I talk about all the noise and stuff in the VC and everything else, taking part every day in a global conversation about how we're going to make our industry better, and all of like the super smart people, I feel like there's an energy right now that has not existed before, and it's going to break out. And I'm hoping that hypar is there to be one of the platforms that enables that breakout to happen. But this conversation in the Discord, on Twitter, on LinkedIn, I love waking up to that.
I see. And what your favorite movie?
My favorite movie is the movie Contact, which was actually one of my favorite books, which everybody laughs at. But I saw the movie Contact twice in the theater on the same day. It was like on its opening day, I went and saw it twice. That's like how much I love that movie.
Awesome. And how does a day in your life look like?
A day, what is a day? They all look different. I try and make them look the same, but that never works. But today, which I'm trying to make a good day, I wake up at about 5:30 and try and connect with the East Coast version of hypar, because we have people in New York, Philly, and on the East Coast, in Boston. And then I get on the Peloton at about 6 a.m. or I go for a run, and I'll do 45 minutes to an hour of that. And then I usually have some version of a planning meeting at like 9 a.m. in the morning for about an hour. And then the days are, I'm doing one of 4 things. I'm having short discussions on specific kind of features and stuff with developers. I'm speaking with potential investors. I'm speaking with potential hires, or I am doing the huge amounts of sort of administrative stuff that just has to be done to keep this whole thing on the rails.
I see. And what is a piece of advice for young professionals and entrepreneurs in AEC tech space?
I do not accept, I mean, if you're saying they're already in the AEC tech space, then they've probably already taken this advice, but I'll just broaden out to architects and engineers, young people coming into the profession. Do not accept the model of the profession that's presented to you as the only way that you can be successful in this profession. Virgil Abloh, the famous designer who just passed away, he was an architect and a civil engineer. How fucking amazing is that?
Yeah.
And that is because my comments earlier about Gilles Deleuze notwithstanding, architecture prepares you for a world of thinking about design and spaces and how people interact in those spaces. And that has an enormous, that creates an enormous possibility space for you. so that's what I would say. Don't take anything at face value, because I honestly think, this young generation is gonna change what our profession looks like.
I see. And you have like some amazing disruptive ideas. So like, do they come in shower on a walk, or like where are the sources or moments for those ideas?
Steve Jobs once gave an interview where he talked about, and you never know whether or not this stuff is true, but he talked about his next door neighbor who did, he would go and find rocks, and then he had this rock tumbler, and he would put these gnarly, nasty rocks into a rock tumbler and run it, and then come back 24 hours later, and you had these beautiful polished rocks. And he talked about that as being a way that like good ideas emerged at Apple. I would love to learn that story is 100% false, actually, because it would actually improve my estimation of Steve Jobs. But it's such a great analogy. Like, no, there's no like shower moments or anything like that. It's just like, hey, wouldn't it be cool if we did this and our users could do this? Let's try it. And then like build the smallest version of that thing and see if in fact it's cool. And then kind of like, no, I don't think we should do that. I mean, there's a lot of conversations where I've had to like come back and apologize to the team after the fact, because I've gotten so fired up about like how things should be. And that's the banging of the rocks, right? I do think it's a great analogy though, because this stuff only comes out of like great conversations in the team and great conversations with your customer.
Nice. And who's your role model?
I don't know. I used to have this binder. It's really cheesy. I used to have this binder. Oh wait, I still have. Oh my God. I can't even believe this thing is still on my shelf. And this is, Meyer, I'm going to open this up because I don't know if, I don't know that anyone has ever seen this, and it's so hokey. Oh wait, I don't have the picture anymore. I used to have a picture in this binder says goals on the, and I started putting this together in college, and it has like my marathon times and stuff from when I was running a lot of marathons. And it used to have, I don't think it has it anymore, but I used to have a picture in there of Bill Gates. I'm so embarrassed to admit it. It was like the Time Man of the Year or something from 1995. And I had a picture in there, and I was just like, man, if this guy can do it, this like nerdy kind of guy who just like wanted to write computer software all day, and then he could turn this into this global enterprise, that there's hope. So somewhere between like Bill Gates and Isamu Noguchi, like in there somewhere.
That's awesome. Like that's very cute that you have that goal book. Do you visit it every year? And you'll
in fact, I didn't even recognize that it was still on my shelf until just now. I'm gonna have to revisit it today though. It's a trip down memory lane.
Awesome. And lastly, is there anything else we didn't cover in this interview and you would like to talk or share?
No, I mean, I think I've talked plenty, but I will say, if you're interested at all in what we're doing at Hypar, come to hypar.io, check it out. You can follow us on social media, on Twitter, on LinkedIn. I think we're on Instagram now too, which is a great way to get active in this kind of global conversation. And then of course we have links on those socials to our Discord server, where Meyer and others are having incredibly interesting conversations around the future of the professions. It's not even like Hypar. A lot of it isn't even Hypar related. It's machine learning and AI. It's just cool new technologies that are happening that are going to impact our space. It's a fantastic conversation. So you can join us there. And then we do occasionally have these Hypar live events that we have on Fridays, where it's actually the team like live, like developing or showing off features that we've built on the platform. And our YouTube channel has past versions of all of those, so you can go and watch them and see what I'm talking about. And of course, if you go to Hypar and you're like, well, I'm not sure if this is quite right for me, you can feel free to reach out to me directly, and we can book some time to talk about whether or not Hypar is right for you.
That's amazing. And I must admit, like the Hypar team is very responsive whenever you post on feature request or if you have any questions. So like the community support is incredible. Thanks a lot, Ian. Like few things which maybe like there's a talk for next time is thoughts on metaverse and blockchain, but it
That is a whole other conversation. I have many thoughts. That's a whole other conversation.
Yeah, it's definitely, but I had a great time, and thanks a lot, really. And it was an amazing talk, and you're building something amazing, and like it could change the future of profession, and I strongly believe in it. So good luck in this journey.
Thank you, Meyer, for the opportunity. And I'm just gonna challenge one thing that you said there. And people say this all the time. You, as in you, hypar, are building this thing. We are building this thing. You know, hypar is only successful if the community adds content to this thing in such a way that we all sort of level up. So I'm always careful not to say that we are building the thing that is going to change. That is hypar, but we as a community are going to build this thing. So,
Yep.
thank you.
Have a nice rest of